Hello, engineers. This is Professor Dan at the University of Colorado Boulder. And today we went through moments and we went a little quick, so I thought I'd slow it down a little bit. Sometimes people could use a little more time really trying to understand this thing called moment. So, what is moment? Moment is something that basically causes rotation about something. And in our case here, what we have is we have a bolt. And so, what we often do is trying to give you some intuition. We have a bolt and we're using this wrench and we're applying a force F to try and rotate that bolt. So how do we do it? So we have this force F applied at a distance R away from this bolt. We're trying to rotate it. And we learned from physics that the vector M, it's a vector and um, it's got direction, it's got magnitude. And we know that if we know vector R and we cross it with vector F, we know that we get the moment. But what often happens is when we are trying to do something in the real world, coming up with vector R and making sure our sign's right and making sure our vector F sign's right is can be difficult. So we learn that we can get the magnitude of M by knowing the perpendicular distance D times the force F. And that's a method, if we decompose our vectors, that's a method that most students often choose when we're faced, especially with 2D problems. So how do we do it? Well, let's decompose the vectors. What does that mean? Well, it means if we have vector F, and you saw it, spoiler alert, it was already up there, we can decompose F into its Y direction, which I'll use yellow, and its X direction. And we can do the same thing for R. So R, in this case, the X direction I'll use yellow, and you'll see why in a second. And the Y direction I'll use red. And so how do we actually do this? Well, what we can do is if we know moments a vector, we actually know that its direction is developed using the right-hand rule. So what we can actually do is we can use our what we know and we can make our life easy. So how does this work? So f of f can get broken down into its components. So f of y, what we learned today is the principle of transmissibility means f of y can slide anywhere on this entire line. And so that can go all the way around the world. But if we're actually trying to find the moment about the bolt due to f of y, well, we can say it's f of y times what's the perpendicular distance? Well, that's just rx. So it's f of y. And then, yeah, the distance is Rx times f of y. All right, that's pretty easy, but what direction does it act in? So one of the things that I like to do is I like to say my arrow is my pointer finger. My pointer finger points in the direction of the arrow. I place my index finger on my right hand in the direction of the arrow, my palm facing that bolt, and I put my hand on that line, and I see that when I curl my fingers, my thumb is facing out. So that's positive. So now, how does f of x work? Well, f of x, again, principal transmissibility means it acts anywhere on that line. And what we see is that going down to the bolt, that perpendicular distance, well, that's just ry. So that's ry times f of x. So the moment due to f of x about this bolt due to f of x acting at a distance ry is just ry times f of x. Now, this is a little strange, though. Put your fingers pointing in the direction of f of x, put your palm facing the bolt, and you'll see that your thumb goes into the screen. So that's minus. So the overall moment is rx times f of y minus ry times f of x. That's a little crazy. And what direction does that act in? Well, we know that that acts in the k direction due to the right-hand rule. And so let's just see, when we do the math, does it work out? So if we do R cross F and R is positive in both directions and F is positive in both directions, well, how does that work? Well, if it's just in two dimensions, we know that RZ is zero and FZ is zero. So anything with an RZ or an FZ is zero. So these terms are all zero and those terms are all zero. And what we see is we have Rx times f of y positive minus ry times f of x. So that's negative. So things are consistent no matter what we choose. So we can use whatever method we work what works, whatever method works best for us. So anyway, just want to go a little slower. Hopefully that helps. And yeah, try practicing this. Try it in different problems, but really try using this vector decomposition. It works well for most students. All right, have a great day, and we'll see you in the next video.